Hi everyone, my name is Maddison and I'm a research scientist in the Northern Territory. I study plant industries, in particular mango production in the top end. And today I'm really excited to share with you some of the work I've been doing assessing the impact of climate change on mango production and some of the findings that we think are really interesting in regards to tropical horticulture around the world. All right, so I'll jump straight into it. So I'd like to start by thanking CRISPI for holding their conference online and also thanking all of the partners of CRISPI as well. So I'd like to start by chatting a little bit about assessing the impacts of climate change in the tropics. Okay, so these are maps of the distribution of tropical regions around the world, and they're defining the tropics using the Köppen climate classification. Now, the top map is current or a little bit dated now, but somewhat current. And the bottom, published about 2 years ago by an author called Beck, and it is distribution of tropical regions by the end of the century based on a collection of climate change projections. Now, based on the maps, it doesn't look like there's a lot of change, but there are some regions that will see an expansion of tropical climates and others where tropical climates are retracting. But overall, we're likely to see a slight increase in the proportion of land cover globally that will fit into Köppen's classification of tropical climates. Now, the definition of a tropical climate as presented here is conditions under which temperatures, monthly mean temperatures, are greater than 18 degrees all year round, and they experience significant rainfall as well. But we also know that the tropics have a couple of other features that are important to food production systems: a distinct lack of temperate seasonality. So instead they get that highly variable rainfall, that typical sort of dry to wet season, little variation in day length, and there's also little variation in temperature as well compared to other climates. So although it looks like there's not much change based on those maps, it has been widely published and discussed now that the tropics will experience more extreme conditions than any other climate under climate change conditions. So these projected conditions, though, don't fit that pre-existing definition for tropical climates or for any climates. As I've got up the top there, published by Colette in 2011, it's likely that majority of the tropics will soon be subject to climate conditions that have not existed anywhere on Earth for millions of years. So what is projected to occur, we actually don't have a definition for, and therefore the maps in the previous slide somewhat disguise the amount of change that's likely to occur in the tropics. So what is the change that's likely to occur? We're going to probably see a decline or increase in rainfall depending on the area, an increase in temperature and temperature variability, more extreme conditions as a result of that, and elevational range shifts. So there'll be a shift in ecosystems up or down elevation. So taking these changes into account, how do we assess the impact on production systems or horticulture specifically? So we need to identify the links between climate variables and production variables. So I've just got a couple of examples on this slide. As you can see, the list you can write of direct and indirect impacts of climate change can be quite long and complex. So it is important to consider all of these impacts and how they are interconnected when you're assessing the impact of climate change. Another thing that's really important to consider is the adaptive capacity of a production system. I've provided some examples there of things that could be assessed and things that are really important when a production system is required to adapt, particularly when there's quite big changes that need to be made to ensure the sustainability of production. Okay, so to provide a bit of an example of this process, as I mentioned right at the beginning, I'm just going to give a brief overview of a project that I have been working on. So the project was a partnership between the National Environmental Science Programs, Earth Systems and Climate Change Hub, and the Northern Territory Government, and supported by industry bodies. So in this particular example, the Australian Industry Association for Mangoes and Northern Territory Farmers Association. So to start with, we had to identify that link to production, so the climate link to production. And in this particular example, we use temperature. So temperature we know is important for mango flowering and therefore important to mango production. However, there isn't a consensus about the specific thresholds to mango flowering and the specifics in regards to cultivars and different regions. So we had an idea of a climate variable that we could use, but we knew that we needed to work further to define it if we were going to conduct an assessment. So for several years, we observed the fate of mango stems in the field at different times of the year and therefore under different temperature conditions. And we were able to identify a relationship between temperature and a proportion of stems that turn into flowers. From here, we've been able to define some thresholds. Specifically, these thresholds are at the point at which only 50% of flowering occurs. And now we knew that we were able to use those to conduct an accurate assessment of impact. So next we access the climate data, and this is provided to us from the team at the Earth Systems Climate Change Hub, climate scientists at CSIRO and the Bureau of Meteorology. And here's an example of the type of data that we needed. So we have temperature thresholds and we wanted to know the number of days that will occur above or below those thresholds. So in this example here, you can see that in the month of July, in the top of the Northern Territory, we're seeing an increase in the number of days above 35 degrees. And you can see that it's variable depending on the area, but overall, there's an increase in the number of days above 35 degrees in most regions. So then we take that information, combine it with our knowledge of mango flowering physiology, and we're able to assess the impact on mango flower induction, so that process of differentiating between leaf production and flower production. So in that figure there, when I say inductive days, the number of inductive days, they're the days where there are conditions that are supportive or inducive of flowering, and that's how we measured impact. So in this particular example, you can see that between now, or historical, which we would use to define as now, between now and the end of the century or 2090, there's a reduction in the number of inductive days, but only in 2 out of the 4 months that we assessed. So we've also been able to identify that the change doesn't occur evenly across the year, of course, and in this particular case, what that would tell us is that mango flowering would become restricted to June and July. So the loss of opportunities for mango flower induction will impact the number of terminals that are produced, flowering terminals that are produced, and therefore the amount of fruit that is set, and then of course the yield as well. And of course, we also assessed adaptive capacity, and just one really interesting example of that for this particular project is we were able to do an assessment just through surveys of the level of understanding of climate change science in industry, and found that there was definitely opportunity to develop that understanding. So we were able to integrate into the project opportunities for climate scientists to meet with industry, to present climate information, and that would develop the understanding of climate change science in industry and therefore improve their ability to adopt and interpret the results that we were going to publish. It could also dictate the way we published information and the way that we then extended that information to industry. So at the end of this assessment, we've got a whole range of things that we're able to use to inform adaptation going forward. So, for example, we have an improved understanding of the mango reproductive system, which gives us the tools to do lots more, to change the way that we manage existing orchards and to also inform the development of new management systems. This knowledge also informs industry bodies and government to plan strategic development of production regions into the future, and also policy development as well. So why is this really important? Now, mangoes are the 6th most produced fruit in the world, just behind oranges. They're produced in over 100 countries and imported by over 100 countries. So there are millions of people whose livelihoods rely on mango production throughout tropical regions around the world. So it's really, really important production system, and it's an important production system to ensure the sustainability of. Now, interestingly, mango production, or the reproductive process of mango production, is also dictated by a range of other temperature thresholds. For example, the pollen viability and the rate of fruit growth are 2 other things that are impacted by temperature. So it's important to consider these assessments for other processes in the production system as well. But beyond mangoes, we know that there are reproductive temperature thresholds for many other tropical horticultural crops that are grown around the world. So they've been widely published. The next step is to just understand what those temperature thresholds mean in regards to climate change impacts. So given that tropical agriculture is expected to play a pivotal role in feeding the world's growing population, and that's likely to occur through the industrialisation of traditional systems found throughout the tropics, it's going to be vital to be able to better understand the impacts of climate change on a full range of horticultural crops that are grown in the tropics. And I've just provided a couple of examples of crops with temperature thresholds that have been published there. Okay, so I hope that gave you a very brief but good overview of our project and its potential implications globally and for other production systems. If you have any questions for me, please don't hesitate to get in touch with me. I've put my contact details up there on the slide, and I've also provided the contact details for Mandy Hopkins, who was our partner in the project from CSIRO, and she's based in the Earth Systems and Climate Change Hub. So thank you very much for listening. Have a great day.